Hey class, so today what we're going to do, we're going to solve systems by substitution. So far we've done graphing and we've done elimination. So the last one is substitution. Remember, graphing is we solved the equation for y, graphed them and found where they intersected. That gives us our solution. Or we could eliminate one variable by adding or subtracting, making sure that they have the same coefficients but opposite signs, so that whenever you add, they eliminate each other. Now what's going to happen is one of our variables has been solved for. The other equation doesn't. So this is set up the best for substitution. So usually if they look like, both of them look like this, we would graph it. If I added the x over, we could do elimination. So you can solve it any of the three ways that we've done so far. But substitution, what we're going to do is I'm going to take my y. So what this means is y is the same here as it is right here. So whenever you see that equal sign, that means I can replace the y with a negative x plus 1. So what that means is I can take this and I can sub it into this equation. So what we're going to do, we're going to take 3x, I'm going to add 3, but now instead of the y being there, I'm going to replace it with negative x plus 1. So we're going to replace it, negative x plus 1, and we're going to set that equal to 3. So now what we want to do is just solve for x. So we go ahead and distribute. So that's 3x. 3 times a negative x, that's going to be negative 3x, and then this 3 distributes to the 1, so that makes it plus 3 equals 3. Alright, so now we combine like terms, the negative 3, and we combine the negative 3, those actually cancel out, and I'm left with 3 equals 3. Now what happens if you get 3 equals 3? 3 is always equal to 3, so we actually have infinitely many solutions. So infinite, make sure I spell this right, many solutions. So what this basically means is these are the exact same lines. If I were to solve one for y and I graphed them, they would coincide, they would be the exact same. So that just means I can put in whatever I want to for x and y, and I will get out the same thing no matter what. So whatever I put in for x, it does not matter, it's going to give me the same y. So I have an infinite amount of solutions because those are the same lines. Alright, so what we did was we just replaced the y, we substituted into the other equation. So here, this equation is actually solved for x. So that means every x I get to replace with a y plus 4. So now we'll solve that one. So my second equation is going to be 2y plus y plus 4, so that was my equation, equals 19. Alright, so now what we want to do, combine like terms, distribute, whatever we need to do, solve for. So I'm going to combine my like terms, so 3y, I'm going to go ahead and subtract 4 from both sides, just kind of expedite the process, divide both sides by 3, and so I get y equals 5. So now that I have y equals 5, I'm going to sub it back into either equation. Now if you notice, this equation already has a y in it, so what we can do is solve for, just plug it in and get x. So x equals y, which we replaced with a 5, plus 4. So x is equal to 9. And remember, we always want to put it in ordered pair. So 9, comma 5. So that is our solution for that equation. Got one more example. Alright, now this one is set up a little bit better for elimination because if you notice, all of our stuff is on one side. Now the problem with this is that I would have to multiply one of these, and so that gets a little bit tricky. Now if you notice, x is already by itself. So what I can do is I can manipulate the second equation a little bit so I can do substitution, because what we want to do substitution. So I'm going to take this equation, I'm going to add 5y to both sides. So that gives me x equals 5y plus 17. So that is my second equation, alright, because I didn't do anything to the 17. Those aren't like terms, so I can't combine them, so I just write them out. So now that I have x here, I can now replace it with my x in my other equation. So my 5y plus 17 now replaces that x. So it's 3 times 5y plus 17 plus 2y equals 0. Alright, so I distribute my 3, gives me 15y plus 3 times 17, That's going to be 51 plus 2y equals 0. Combine my like terms, so that's 17y. I'm going to go ahead and subtract 51 from both sides, so that gives me negative 51. Divide both sides by 17, so my y equals negative 3. So that's y equals negative 3. So now we take this negative 3, sub it back in for either of our equations. Now if you notice, this one has already been solved, and all I can do is just sub that in. So I got x equals 5 times negative 3 plus 17. So that's x equals negative 15 plus 17. So x equals 2. And then we report our answer as an ordered pair. So that is our solution for our system of equations. That is how you solve systems by substitution.